So in the last lesson, we talked about the generic groups on the periodic table. Now we're going to talk about the more specific groups. And one group we've already talked about, it is this group over here. It is group number 18, which is that last column on the periodic table. And we gave it a name. I briefly mentioned its name, if you picked up on that. And its name was given as the... There it is, right there. I'm trying to write on this sideways. This makes it very difficult. Oops. Let's try it this way. There we go. Noble. Oh my. Gases. Boy, that is nice and legible, right? Yeah. Well, we're going to write that down below in a text box, all right? So we can make it nice and legible that way. Group 18 is known as the noble gases. I know that clicking is nice and loud, but my keyboard has to be close to my microphone for this, so I'll try not to talk while also typing. Group 18 is the noble gases. They are known for being mostly, well, actually, it's not even mostly. They are really all gases at room temperature. And that's why they're called gases. Why are they called noble? They're called noble because they are non-reactive, will not associate They do not mix with other elements, and that's actually where the name noble came from. They're sort of seen as these hearty and high and mighty elements that won't deign to associate with all these other lower elements. So the noble gases, right, are non-reactive, don't associate. They are therefore mostly non-hazardous. They have their own hazards, of course, right? Any gas can be a hazard because a gas, say if a gas fills a room, it can force all the oxygen out of a room. So any gas can be hazardous in that respect, but noble gases are sort of seen as non-hazardous because you inhale them, most of them every day, and they don't really harm your body. Radon is, if we look up at group 18 here, radon is sort of the last one in that group. It's an exception to that, but it's radioactive, and that's what makes it harmful. The next group over is, to me, the one that makes the most sense to talk about next is group number 17. And group number 17 is a group known as the, black ink will do just nicely here. And around, this is known as the halogens. Fun story for you here. You're going to notice there's a lot of gen names on the periodic table. And gen comes from a Greek root meaning to make from. And so group 17 is known as the halogens. And they are known as the halogens because halo means sea or ocean water. And the first halogen discovered was chlorine, and it was actually isolated from salt water, from seawater, from ocean water. So group 17, the halogens, in sharp contrast to the noble gases, are very reactive. You can mix them with just about any element on the periodic table, and they're going to react with it. Yes, we can even, if you give them a little extra energy, they will even force the noble gases to react. Kind of fun. Or if you compress them all together. You're familiar with these halogens. Most of you have heard of halogen lights. Halogen lights come from the fact that there's iodine in them. You also use chlorine and bromine, for example, in pools, right, to sanitize. They are very reactive. They are also poisonous, basically to all life forms, but especially lower life forms like bacteria and viruses have a hard time dealing with even small concentrations of halogens. Your body can slough off some of that, and that's why you use iodine, for example, to clean up cuts, and fluorine, in your toothpaste. But halogens, very reactive, very poisonous, and what's really interesting is all three states they have a solid at room temperature, which is iodine, a liquid at room temperature, which is bromine, and gases at room temperature, which are chlorine and fluorine. So that's kind of an interesting fact that you can find all three phases of matter, or all three states of matter, in the halogens at room temperature. Group 16 is known as the Chalcogens, but there's not really anything associated with that. And, Group 15 is known as the Pnictogens, Pnictogens. But those are, but mostly, really the only non-metals you need to know about are the noble gases and the halogens, at least for Chemistry 1. So to jump over to metals, I just jump all the way over to the other side here and put a 1 up there because the next one is Group 1. I'm going to stop trying to write these on the periodic table. It just takes too long. So Group 1 is known as the Alkali Metals. And if you don't remember, alkali means that it has a high pH. And literally the name for these things came from, they were found in compounds that have high pH. Oops, little p, big H. Or lowercase p, capital H. One of the most famous of these is lye. Lye is a compound that's been used for years and years and years to make soap. You take it and you mix it with water. It makes a very high pH solution. Then you can mix fats or oils into it, and what comes out of that is soap. Lye is sodium hydroxide. Sodium being the alkali metal that's in that. These are also very reactive. These are the very reactive metals. They react violently with water. So if you ever, you can Google, right, the video of lithium or sodium or potassium being added to water. There's even one of cesium, which is super duper explosive. Very fantastic, very reactive set of metals. The Group 1, the alkali metals. What's really interesting to me to the alkali metals is basically you need all of them in some form or another to live. With the exception of perhaps cesium and rubidium. I think your body even needs just a tiny bit of rubidium, but you need a lot of sodium to live. You need potassium to live. People are very familiar with what low sodium, low potassium can do. Lithium, interestingly enough, can be used to control mood swings, to control a lot of activities out of the brain. That's kind of interesting. And hydrogen, well, we're going to talk a lot about hydrogen when we get to pH. All right, so that's Group 1. Group 2 is very similar, so be very careful on this one. Group 2 is known as the alkaline earth metals. Alkaline earth metals. So alkaline earth metals are also found in compounds with medium to high pH. So these are not nearly as alkaline as their cousins, the alkali metals, but they do still form compounds that make alkali solutions, that make alkali chemicals. They are somewhat reactive. They are, again, just like you may have seen this in the Mendeleev activity, right? They are very close in properties to the alkali metals, but they're just a little bit less. You know, the alkali metals are extra. These guys are a little bit less. These guys are somewhat reactive, and of course, what's their name? Alkaline earth metals. These are mostly found in Earth's crust as chalks. Chalks are a kind of compound. We always think about, when I say the name chalk, everybody thinks of sidewalk chalk or blackboard chalk, if you've ever seen one of those old blackboards. But chalks are actually a class of compounds. There are all these kind of gritty, powdery substances. And this is where the first alkaline earth metals were found. Were actually found in chalks with oxygen. Most of them were found accompanying oxygen. And so you look at the Group 2, you got beryllium, which is super poisonous, but then you got magnesium, which your body needs apparently for energy. We're not entirely sure what your body uses magnesium for. But calcium you need for bones. You need a little bit of strontium to help that calcium out. Barium you don't need at all. Barium's actually incredibly poisonous. So you've got some of these that are essential to life and some of these which are poisonous. And then radium, which gets its name from being super radioactive. That's kind of fun. Group 2, alkaline earth metals. All right, so now we go to an entire section of the periodic table. And if you remember this middle section on the periodic table, I'm going to draw a box around it again. make a semi-transparent box. If you remember doing that, then you're in good company, because I certainly remember doing this. Oh, I forgot to fill it in. Fill that box in, right? Yeah, we're going to fill this box in. Remember, this group right here is known as the D block. So that is an entire section on the periodic table that gets a nickname, and that nickname is, oops, let's put an equal sign so we stay the same, transition metals. Those are also known as the transition metals. And that name, transition metal, comes from the fact that you are transitioning from the S block over to the P block. But all the metals in the transition metals tend to show sort of the same properties. And their properties are high density. Most of the transition metals tend to have high density. Not all of them, right? But vast majority of them tend to have pretty high density. The most dense element on the periodic table is iridium. It's right there in the middle of that D block, right there in the middle of the transition metals. And one of the most dense substances on Earth is an osmium-iridium alloy, where we mix these two elements together. So high-density elements here in the periodic table. They also tend to have high melting points, though that's not universal, because I'll point out one to you, is mercury is in there, and mercury is liquid at room temperature, but most of them tend to have high melting points. They are also tend to be great conductors. They're great conductors. Now, most of the metals in the S block are only okay conductors, and the ones in the P block are actually kind of terrible conductors. But in the D block, those transition metals, they all tend to be great conductors. One of the best ones is gold, and that's why inside your Chromebook right now, or inside your laptop, or inside your computer, there's a tiny, tiny, tiny amount of gold. Now, it's not worth a lot because there's just a tiny, tiny amount of it, but they take it and hammer it very thin, and it's used as conductors inside of computer components because it doesn't generate heat when it conducts electricity. The last group on the periodic table that we're going to talk about is this group down here at the bottom. Oops, I forgot I had one selected, sorry. This group down here at the bottom doesn't need to be in red. Let's add just another color on top of that. Let's see. Oh, I like that. I like that mixture of colors right there. Here in purple, or some variation of purple, what we've got is, you guys remember that as the F block, okay? And the F block are also known as rare earth metals. Gee, why are they called rare? Why are they called rare earth metals? Because they are found in low percentages in Earth's crust. One of the rarest elements on there, but one of the most valuable to us, is uranium. Uranium is in here as element number 92. Element number 92 is the last element you actually find in nature, but it is a very rare one, but it's very useful because we use uranium to actually make some of these other elements. So some of the F block, some of the rare earth metals are man-made. And we'll talk at the end of the semester exactly how you make these man-made elements. Many of these are radioactive. Many of them are also really dense, also very dense. But they are so rare you often find them coupled with other transition metals. So, for example, cerium, which is here, cerium and lanthanum are often found, in tiny percentages in things that have a lot of iron and nickel in them. So many of these are very, 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 very rare, very difficult to find, difficult to isolate. But these are all of the elements on the periodic table. They all kind of, you say, wait, it's not all of them. Yeah, there are some other P block elements, but most of these groups don't share properties, so we don't really worry about naming those groups. But if you were asked to identify, right, for example, if you were asked to identify plutonium, what sort of properties would you expect to find for plutonium? Well, it is an element that is probably very dense, found in very low percentages in the Earth's crust. It may be man-made. If I asked you, what about calcium, for example, you'd say, well, calcium is found in medium to high pH compounds, somewhat reactive, mostly found in Earth's crust as a chalk, where it's combined with oxygen. But that's just sort of the idea.